what distinguishes functions and objects from the numbers, the strings, the booleans that we've seen so far is that they're mutable, which basically means is that we can actually change them, right? This is a concept that we'll talk more about in the full-time curriculum. Essentially, the caveat here is that if I have a number, I can't really change that number. As in, 6 will always be 6, right? 5 will always be 5, true will always be true. And in the case of JavaScript, a string is always going to be a string. What I can do is I can replace that with a brand new value, but I can't edit the value that's already pre-existing. The difference then there with a function or an object is that I actually am able to edit or modify those data types once I've created them. We won't talk too much about mutability in this class. Like I said, it's a topic that will come up in future curriculum. But just kind of keep in the back of your mind that that functions and objects are things that are a bit more advanced, and a lot of that is because it is able to be changed, right? It is more customizable than the strings, booleans, and numbers that we've seen so far. So can everyone see? No, no one can see my screen. I just realized that. Okay, can everyone see my screen now? Yes. Do you see a slide that says function on it? Okay, great. Thanks, guys. Cool. Okay, so a function, right? And this slide should look familiar because we've gone over on the first day. A function is a reusable piece of code, and really functions are the backbones of most programming programs. And basically the reason why that is because if you really think about what a computer is designed to do, right, is computers are really, really good at handling high volumes of precise problems. As in, if I write a function that, or rather, if I write a piece of software that's only supposed to kind of do one thing one time, well, a lot of times it's probably easier for us to just either do it manually or for us to handle it some other way. However, if I want to, process a million pieces of data as opposed to just one piece of data, well, then a computer becomes almost invaluable, right? Because no human or even machine, for that matter, can really process a million pieces of information either concurrently or sequentially, whereas a computer can. And the way the computer does that usually is by doing the same process on the data over and over and over again. And so this brings up to something we talked about on the very first day of class, which is that program or computer languages are very good at repetition, and so functions are a big component of that. A function is a reusable piece of code that you can basically run, and what it will do is it will just process the information over and over and over again. Functions, let's go to the next slide. Actually, it's a bit more easy to kind of see the anatomy of a function. Functions are things that we create, and you can create it two different ways. The way we'll talk about it, the way we'll talk about it is in this case we'll use the function keyword as a declaration. So in this case, the way for us to create a function is if I started line 1 there, I start with the actual word function. If I type that in a code editor, it will probably show up in a different color. Function is also a reserved word in JavaScript, which means that you cannot have a variable called function. You just write function, and then after that, you write the name of the function. Right? This could be anything that you want, as long as it follows the traditional JavaScript naming convention. So in this case, we've created a function called add 4 numbers. Okay, that's the name of our function. After add 4 numbers, we have an open parentheses followed by a bunch of values and then a close parentheses. What are the things in those parentheses? Well, those are what we call arguments or parameters. The difference is more semantic. I might use the words interchangeably. Essentially, what those things are they're the pieces of information that I feed into a function, right? So if you really think about kind of on last Wednesday, when we talked about JavaScript, we said, hey, what JavaScript does is, or what most computer languages are kind of focused around doing is taking a piece of input data, transforming it or otherwise doing something with it, and then giving an output, right? And so these things here, all the values in between those parentheses, those are the inputs. Those are the functions that we add, that we give into each function. And so if we just even look at here, right, the name of the function is called add 4 numbers. And without going through in too much detail, you can kind of imagine what it does is it takes in 4 numbers and then it adds it up for you and gives you back the sum. That means every time we run the function, it's going to take 4 numbers, But those could be different numbers each time, right? A function wouldn't be very much useful if all it did was add the same 4 numbers each time. And so with those values in between the parentheses, notice how there's 4 values. There's num1, comma, num2, comma, num3, comma, num4. The comma basically separates the different values that are input into the functions. And so num1, num2, num3, and num4 are variables, right? They're placeholders for they're placeholders for values that we are going to put into this function each time we call it. Does that make sense, everyone? Every time we call this function, we are going to feed it in 4 new numbers. But within the confines of this function, we don't need to know what those numbers are. We just need to say, hey, num1 is going to represent the first number, num2 is going to represent the second number, and so on and so forth for nums 3 and 4. Okay, so once again, we have our function keyword, we have the name of our function, and then now between the parentheses, we've defined what's going to go into the function. Not all functions are going to require external pieces of information, but even in those cases, we still need the parentheses. And in that case, if it doesn't require any input of information, then we'll just leave it blank. But we always need those parentheses there to acknowledge that, hey, this function takes in either a variety of arguments or it takes in no arguments. Yes? Mm-hmm. We can call this like a variable declarator. Yeah. VAR, you mean, on line 2? Yep. The difference it has something to do with something called scoping. We won't talk about it in this class. For this curriculum, like to the extent that we'll use it, you can think of them as interchangeable. And they both create variables. In the real world, you'll probably see people using let going forward as opposed to var. Let is just a little bit more precise in saying if I create this variable here, I'll be more precise about defining where I cannot use this variable. But that won't be an issue that should come up for us in this course. I'm sorry, it will what? Yep. Yeah. Whether or not you use let or use var in this case, it wouldn't matter. You would get the same exact outcome. Yep. Any other questions? Okay, so now we've defined the name of the we've now defined the name of the function, we've defined what goes into the function. We then see this open curly brace, a bunch of code in between the curly braces, and then the closed curly brace on line 4, right? And so everything in between these curly braces are going to be the body of the function, right? Essentially, this is going to be the piece of the processes or the piece of code that we're going to reuse over and over again. In this case, on line 2, we're creating a variable called sum, and the value of sum is going to be num1 plus num2 plus num3 plus num4. And then after we create this variable called sum, we then return sum. Return is a pretty interesting tidbit, and I think the reading was going to give you a little bit more context around it. But just know that what return does is a lot of times people confuse console logs for returns, and just know that they are fundamentally different things, right? A console log is something that prints to the screen for us to check. A return is actually the function giving back a value. And so, for example, on line, I guess 5 or whatever, the line in black there, right? I'm creating a variable called mysum. I'm setting equal to add 4 numbers, and then I'm invoking the function. Okay, so how do we actually run a function in JavaScript? We have to use the open and close parentheses. If we don't use the open and close parentheses, if I just say var mysum equals add 4 numbers and end it there, that means I'm setting that variable mysum equal to the function itself. But when I write the name of the function and I put an open and close parentheses after it, like I do here, now I'm saying is run the function and set the variable mysum equal to whatever the return value or the output of that function is once I run it. So in this case, I'm running add 4 numbers. I'm feeding in 4 numbers there. I'm invoking it, or when we run a function, we call it invoking a function. And I'm feeding in the numbers 1, 2, 3, and 4. Okay, and so within add 4 numbers now, I'm invoking the function. I'm giving it 4 values, and so within the function itself, the variable num1 is going to equal 1. The variable num2 is going to equal 2. And the variable num3 is going to equal 3, and the variable num4 is going to equal 4, right? Those match up in sequence. So num1 is corresponding to the first argument because it's a first in that list of arguments. And so that's going to correspond to the first value that's being fed into add 4 numbers when I call it on the bottom there, right? So the first value, no matter what it is, it's going to be represented by num1. The second value is going to be represented by num2, and so on and so forth. Now I create a variable called sum. I add up 1, 2, 3, 4, which is going to give me 10, and then I return 10. Okay, the return is, to kind of bring this back full circle, the return 10 or the return sum is very important because now when I go back to my very last line, the black line on line 5 or 6 there, on the right hand side of the equal sign, I'm invoking this function add 4 numbers. I'm feeding in 4 numbers. I'm running the function, and it's almost like that the right hand side of the equal sign goes away and is replaced by the output of the function. And the output of the function is just a number 10. And so that becomes var mysum equals 10. And that's how a function is both made and how a function is run. So the two main things here that trip people up is, once again, a function is not run until you put the open and close parentheses after it, right? If you just write the variable add 4 numbers, well, that could be anything, right? That could be a string, that could be a number, that could be a boolean, it could be anything. But if I put an open and close parentheses after it, it means now I'm trying to run it. And you could only run functions. And so as soon as you see a variable with an open and closed parentheses after it, that means now you're dealing with a function. So running a function is different than just naming a variable or using the variable. And then secondly, the return is very important because the return is the part of the function that actually gives the value back. One thing to be aware of is that in a function, as soon as your function returns something, the function ends. So here, if I have another line of code after return sum on line 3 there, it would never run, because what a function does is a function is saying, hey, look, as soon as I hit a return value, I'm going to give it back to you, and then I'm done. I fulfilled my purpose, right? I've done the calculations or whatever it is I need to do. And that is why almost always you will see the return or some variation of it as the last line in the code. If a function returns something, it will either do it, it will most likely do it on the last line of the function, or it will do it somewhere else where basically like the author is okay with the function ending right there. And then once again, that's just because once a function hits a return statement, once a function returns something, the function is going to terminate right there. Okay, any questions on functions? Any questions at all on functions? Okay, so then the next thing we're talking about is an object, and we touched on this very briefly at the last Wednesday, right? What is an object? An object in JavaScript, the technical definition is it's an unordered collection of key value pairs. So quite a mouthful and maybe not really helpful. In Python, which is another programming language, they actually call objects dictionaries, which I actually really like the analogy of. And the reason why is because if I say an object is a collection of key value pairs, that might not sound like it makes much sense to most folks who aren't programmers. But if I say a dictionary is just a collection of words and their definitions, that hopefully makes a little bit more intuitive sense to people, right? When I go into a dictionary, all it is a collection of word definition pairs, right? There's a word, and then there's a definition matched that word, and a dictionary is just a long list of words and their definitions. That's exactly what an object is as well. And so in this analogy here, the object will be the dictionary, the key will be the word, and then the value will be the definition. Okay, so whenever you see us say a key value pair, if it makes you think about it a little bit easier, think of it as like a word definition pair. So in this case, then the words or the keys are going to be string values. And one of the things that you'll quickly see is that JavaScript objects, in JavaScript objects, the keys have to be strings. Okay, they have to be strings. Just like how if I was looking at most traditional dictionaries, the words have to be alphabetical or alphabetical at the very least. If I'm talking about an English dictionary, right? Like I can't look up a word that starts with an ampersand or a word that has like a at symbol or something in the middle, right? So same thing here with JavaScript. The keys of the object have to be strings. The values, on the other hand, or rather the definition match up to that word, can be anything you want it to be, right? And if I think about a dictionary once again, right, the words have to be, alphabetical in English. The definitions can be a picture, it can be more words, it can be a chart, it can be anything, right? And so that analogy works very well here, whereas the keys have to be strings, but the values can be anything you want it to be, right? So in this case, we have an object with a bunch of values that are strings, but once again, the values could be other data types. It could be booleans, it could be numbers, it could be arrays, it could even be other objects. And so the anatomy of an object is on line 5 there, I'm creating a my object variable. I'm setting it equal to something. And then the beginning of the object is the open curly brace. I have on line 6 and 7, there I have a list of my key value pairs. Everything to the left of the colon is the key. Everything to the right of the colon up to the comma is the value, right? And so here on line 6, in my first key value pair, the key is a string key1, colon, and the value matched up to that key is the string value1. And what the comma means is basically, here's a key value pair, and then I move on to line 7 and look at another key value pair. And whenever I'm done creating my object, I put a closed curly brace there to let people know that my object is over. And now between lines 5 through 8, I've created an object called my object, and there's two key value pairs. In the first key value pair, the key is key1 and the value is value1. In the second key value pair, the key is word1 and the value is definition1. Any questions? And so this begs the question of how do we actually access the values in the objects? Well, we access it using something called bracket notation. There is something called dot notation as well, which we won't talk about too much in this class. Bracket notation is a little bit more flexible and a little bit more universal. But essentially, if I want to access any of the values, kind of like if I go to a dictionary, I say, hey, I want this definition. Well, how do I access the definition? I look for the word, right? So in an object, how do I access the value? Well, I look it up by the key. And so on line 10 there, I have console log, and then inside of it, I'm looking in the my object. And then if I use that bracket notation there, and I feed in the a string that's a key, then I'm going to get back the value associated with that key. And so here on line 10, if I do my object and basically use the bracket we call the index, if I look up the index for key 1, well, the value that matches up with the index of key 1 is value 1. And so why are objects useful? Really, it's because you might have heard of arrays, which is another way for us to just collect a random list of information. The reason why arrays can be useful is if I have a list of uniform information, it's very, very nice to like kind of collect things in one go, right? But what arrays don't do is they don't give me any context for what the definition for what those values represent, right? And so here on line 2, I essentially have an example of an array that just has 3 kind of seemingly random values. One's a string called Pusheen, one's a number called 7, and one's a string called Gray and Tabby. So an array is a good place to hold information, but it doesn't give you any context around it. If, however, I took Pusheen and made it into an object, notice how now I can still store the values of Pusheen, 7, and Gray and Tabby, but now what I'm able to do is I'm able to associate a key with each one of those values, right? It's kind of like having a dictionary in which all you have is definitions, but you don't have the words matching up to them. You can find a definition, but then you don't actually know what word is defining, right? You don't have a proper context around that. Same thing here. And if I use the object on lines 10 through 14 there, right? On line 10, I create a variable called Pusheen. I start my object because I have an open curly brace there. On line 11, I have a key value pair. The key is a string name, and the value is a string Pusheen. and then I have a comma to denote that that key value pair is over. On line 12, I have my next key value pair. The key is a string age. The value is the number 7. Remember, the value can be any data type. Okay? And then lastly, on line 13, I have the last key value pair. The key is a string color, and then the value is the string gray and tabby. So once again, creating an object. Hopefully we've already kind of done this. Line 6, we've used an open curly brace. On line 7, 8, and 9, one of the things that we've kind of done here is we've omitted the quotation marks around the key names, right? So rather than saying string name, we just say name. A JavaScript object lets you take this shortcut where basically any key that you make, you don't have to specify it as a string because in JavaScript, because the keys can only be strings, what JavaScript is going to do on your behalf is it's going to take whatever you write and it's going to forcibly convert it into a string. And so because of that, you don't have to put the quotes around name, age, and color. But that's because JavaScript is making the kind of the assumption on your behalf that that's that is what it is, and that's going to be a string. And so accessing the values is the same as basically putting the string into the brackets that correspond with the object keys, right? So here if I do Pusheen and I use the bracket notation and I put in the string name, that's going to give us the value associated with name, which is Pusheen. If I do it with the string age, it's going to give me the number 7. If I do it with color, it's going to give me gray and tabby. And last but not least, if I put in a string that's not a key, in JavaScript that doesn't trigger an error. We won't say that key doesn't exist. Instead, what we'll give you is the value of undefined, right? So name gives you Pusheen, age gives you 7, color gives you gray and tabby, and if I try to access a key that's not in a dictionary, it just says undefined, right? As in this value doesn't exist yet. So just be careful there, and that JavaScript, it won't break. It will just give you an undefined value. And then last but not least, and this is something that we're going to do a very kind of high level touch on, just to combine what we talked about earlier with functions here, right? The value of a key value pair in a JavaScript object can be anything. It can be a string, a number, which we've already seen. It can also be a function. And here on line 5, so on lines 1, I made a function called gracehopper. On lines 2, 3, and 4, I have first, last, and rank as my keys for and then my values are 3 different strings. That's all cool. On line 5, notice how my key is once again a string called my method, but the value in this case is actually a function. And so here we actually don't need to name the function because we've already named the function. We're already storing it under the my method key. And once we do that, the rest of the function looks identical to what we've just talked about on the previous slide, right? We have our function keyword. We don't need a name because we already have it. Notice how after the function we have the open and close parentheses, which tells us what we're taking in. And in this case, it looks like this function takes in no extra information. We have an open curly brace. On line 6, we have the body of our code. And on line 7, we have our closed curly brace indicating that function is over. And so if I ever want to use this function, I would just do the gracehopper object. I would use dot, right? And what dot does, and this is just kind of take this for granted for now. We'll talk more about dot notation in the full-time curriculum. But when you use dot, what it does is that enables you to basically access a key in the object. And once again, notice how it dot my method. But gracehopper.my method, it's not running the function. It's just saying here is a function. Only by putting the open and close parentheses after my method am I now explicitly saying, hey, run this method. And so when I do gracehopper.my method with the open and close parentheses after it, I am now running or invoking the function that I created on lines 5 through 7. And so that's why the message console logs out, I'm from a method. Any questions? And that was it. Like I said, it's a super short lesson today in terms of like the number of slides. The material could be a bit dense, and as you work through the workshops, trust me, there'll be things that trip you up here. Just remember that computers, once again, are highly logical machines. If you ever get stuck in your code, try to put yourself in the shoes of the computer and think about what you would do and kind of what the computer is designed to do, right? And step through each part of the process like the way a computer would. And that's honestly the best way to probably triage or kind of figure out what most issues are.